Okay, good afternoon, everyone. Welcome to the session for OMS Disaster Recovery. I'm the GPM of Azure Site Recovery, a disaster recovery service in OMS. How many of you have heard of Azure Site Recovery? Oh, all of them. Okay, that's the reason you are here. And I understand that this is a just lunch session, so I have a tough time to make sure you don't sleep during the session. So I'll try to show you as many demos as possible and keep the contents minimal. So with operations management and security is Microsoft's hybrid cloud management suite, which provides hybrid cloud management for your private cloud, for your public cloud, be it AWS, be it Azure, and it consists of multiple services, be it log analytics, automation, backup, and disaster recovery. In today's session, we will drill down into what is the disaster recovery capabilities inside Operations Management Suite. Now, when we think about disaster recovery, the kind of terms which comes to our mind are like hurricane, the flood, the storms, and thanks to Mother Nature, majority of applications downtime are not because of these reasons. Actually, there's a research from Forrester which talks about majority of the application downtimes are caused by operational reasons, be it a power failure, a software failure, a network failure, hardware failure. And human error is also one of the most common cause for applications to be down. In today's world where the whole business runs on IT, anytime our applications are down, it impacts our trust with our customer, it impacts our company's brand, and it ends up having revenue loss for the company. So when we talk to our customers, it's ironical that we find majority of the customers do not have good disaster recovery solution to get the kind of application availability they desire. And the top two reasons why they are not able to implement disaster recovery the way they want are cost and complexity. Traditionally, disaster recovery has been offered where you have to set up your own secondary data center, buy SAN arrays, expensive SAN array replication, and it's huge amount of cost. Also, to enable disaster recovery, how do you protect all your environment? How do you get all your applications running on the other side? There's a lot of complexity. How do you do DR drill without impacting production? And the reason because of these two challenges, majority of enterprises today are not able to protect their application for the kind of RPO, RTO their businesses are desiring. A lot of time, only a few set of applications are protected with disaster recovery, and a lot of applications, they just send the data offsite to a tape vendor or things like that. Now, if any time your application is down because of any of the prior errors, and you have used mechanism like offsite data as a mechanism for disaster recovery, I don't think anybody can save you. It takes days and days to bring your applications. So if you are using that as a mechanism and you hit an application downtime, my advice will be don't try to recover the application, try to find a new job, because there's a research that more than 50% of the companies who don't have good DR don't even reopen after their applications hits by those failures. So at Microsoft, our vision is to democratize DR. We want to ensure every application, let me re-emphasize, every application has disaster recovery. And with that vision, we created Azure Site Recovery, which provides, of course, traditional site-to-site DR scenario, but the main scenario Azure Site Recovery enables to handle cost and complexity associated with DR is our DR to Azure scenario. In a DR to Azure scenario, as a customer, you don't have to buy another data center. As a customer, you don't have to buy expensive SAN arrays, replication, and so on. Azure is your extended data center, and you can perform failover into Azure. This is a disaster recovery solution which works across platform, be it VMware, Hyper-V, and even physical. We hear you that some of your workloads are still running on physical. And many times those are the workloads which require disaster recovery than many workloads running on VM. So we understand you, and our disaster recovery solution even protect your physical workloads to Azure. The same technology also enable migration. All the customers we talk to are in this journey of adopting cloud. Every customer is looking for a different scenario. For the cases where a set of your workloads you want to migrate into a public cloud Azure, Azure Site Recovery is your solution to migrate those workloads. And again, it works across VMware, Hyper-V, physical workloads to Azure. It works across Windows, Linux. Not even that, we even allow your AWS workloads to be migrated to Azure. We even allow you to migrate workloads between Azure regions. Like Azure is continuously creating new regions. So in the past, you may not have a region of your choice and you deployed your application in another region. Now, once a region comes to your data center, close to your environment, you can use ASR and migrate those workloads. Now, ASR has a set of core capabilities and enables multiple scenarios leveraging those core capabilities. The most foundational capability it has is a replication channel. And this is not a snapshot-based backup or data replication channel. It's a CDP replication channel, so that you get world's best RPO and RTO. Our RPO is in seconds and RTO is in minutes. We provide you no impact DR drill. A lot of customers who even bought DR are not comfortable or do not have confidence that when applications are down, will my DR work? And the reason for that is they do not perform DR drill regularly. With ASR, we give you a capability where ASR will create a copy of your environment on a target site in an isolated network, and you can perform DR drill as many times as you want. No impact to the production environment. Even the replication is continuing when you're doing the DR drill. We, of course, provide planned and unplanned failover. Our vision is to provide you application availability. So when an application is down, you have a big red button, you press the button, and the whole application fails over into Azure. To enable that, we have a capability called Recovery Plan, and I'll show multiple demos that how you can fail over a complete SharePoint farm in Azure in a matter of few minutes. Again, we have a very strong viewpoint about what a DR is. As we saw in the Forrester research, that a lot of failures are operational failures. So they will be over in a day or couple of hours and things like that. So when you fail over your workload to Azure, you also want to make sure when the site is up, that operational failure is over, you can bring back your workload to the source site. Azure Site Recovery ensures the promise. It's not Hotel California that you can only go to Azure and don't come out. We ensure that the same simplicity of failover to Azure is available to you when you want to fail back to the on-premise site. And as we talked about, the same technology you can use to migrate any workloads to Azure. Last but not the least, the DR drill capability, which can create a production-like environment in your target site, is very useful capability to get a production-like environment. So if you want to deploy a new patch, you want to test that patch, use ASR, do a DR drill, get a production-like environment, test your patch, and when you're confident, apply that in production. So Gartner has recently released DRaaS Magic Quadrant, and no surprise, Microsoft came as the leader in that Magic Quadrant. So if you are using Azure Site Recovery, you are betting your career on the leaders in the DRaaS Magic Quadrant. Okay, so with Azure Site Recovery, how we enable application availability. Like this is a typical 3-tier application where you have a DB tier, app tier, web tier, and Active Directory. Azure Site Recovery has an app-agnostic replication channel, and it's a service designed grounds up for public cloud DR. Let me re-emphasize, it's a service designed grounds up for public cloud DR. We are not using a DR technology available 5 years back and enabling Azure DR. So the benefit of that is when there are any changes happening to the source component, be it DB tier, app tier, web tier, all these changes go and sit in Azure storage. So in the steady state, you're not running any workload in Azure. That is huge. It not only saves your cost to set up a new data center, even at a steady state, you're not running anything. So that's a huge advantage of having a first-class DR service. Now we also support application-aware replication. So for example, there are some very common application-aware replication. For example, for SQL, we have SQL Always On. So you can use SQL Always On to replicate your changes to Azure. And in this case, when you're using SQL Always On, you will run a SQL VM in Azure. For app and web tier, you will use ASR replication, so the changes will reside in Azure storage. And for Active Directory, you can also use AD replication, so you have a VM running there. The cool point is, even in this scenario, where you're using multiple replication channel, ASR provides you one-click failover of this multi-tier application when your application is down. Okay. So by default, ASR replication is application agnostic. So the benefit of an application agnostic replication channel is any application you can protect with ASR. That's the way a lot of DR vendors are there in the market. They also have app agnostic replication channel, and you can use them. What ASR team has done is went way above than the industry, and we have gone to each of the Microsoft workloads, be it SharePoint, be it Exchange, Dynamics, SQL, System Center, and so on and so forth. And we have certified DR or application availability for those workloads using ASR. So with ASR, you are getting a certified app availability solution for each of the Microsoft first-party workloads. So when we were working with these applications, a lot of interesting capabilities came which you need to build in your replication channel to ensure that when a SharePoint site is failed over, it comes in a consistent state. So we invested in capabilities like VSS Snapshot, app consistent replication. One of the most critical capability is that when you have a multi-tier application, as we saw in the earlier slide, and you're replicating those changes, is there consistency across all the tier of the VM? That is a capability was earlier available only with SAN arrays. Now ASR software-based replication gives you a capability to do multi-VM replication. Also, we work with workloads like SAP and Oracle. And last but not the least, when you fail over your applications to Azure, you do not need to pay a secondary license for the application to run in Azure, as long as you have a software assurance. Okay, so with this, let me quickly jump into the demo. So to use Azure Site Recovery for a VMware environment DR to Azure, Azure Site Recovery is available in Azure Portal. So you can go to Azure Portal, and the first step you have to perform is create a recovery services vault. So let's create a recovery services vault. The name of the vault, let's say Ignite Demo. There might be too many Ignite Demo vaults this week. And you can select a resource group, or you can create a resource group. And Azure Site Recovery is available in the geos across the world. Again, we understand our enterprise customers' requirement. You have compliances that the data available in Europe cannot go out of Europe. The data available in China don't go out of China. So Azure Site Recovery has locations all over the world, and based on your compliance need, you can select a region, and then all your data will be protected in that region to meet your compliance needs. So this is as simple as creating a recovery services vault. Now, once a recovery services vault is created, the first step is a one-time infrastructure setup. So you have a VMware environment. You want to protect this environment to Azure. What you have to do is go to your recovery services vault and say settings, getting started site recovery, and perform a one-time only infrastructure setup. So it asks me, what is my goal? I want to protect my virtual machines to Azure. And these virtual machines are virtualized with VMware environment. Then it asks me about the source information. So this is the place you can set up a server on-premise in your VMware environment called a configuration server or process server. So you can download the server from here and set up. Once you have set up that server, the next step is to add your vCenter to Azure Site Recovery. So you can provide the vCenter IP address or a friendly name, the port number, and with this connection, Azure Site Recovery will discover all your vCenter information and be able to protect your VMware workloads. So in this case, I already have the configuration server and vCenter selected. The next step is to tell about the target details. So for example, which is the Azure subscription you want these workloads to be protected. Azure Site Recovery is a first-class multi-tenant service. So you can create different customers with different subscription. And then we also check for the VMware to Azure replication to succeed, do you have any storage account? Do you have a network so that when ASR will fail over the application to Azure, there is a network to which these applications can be connected. So we found that there were enough storage account and network. The next step is creating a replication policy. So creating a replication policy is very simple. You provide a name. It's a replication policy for your VMware or physical workloads to Azure. What is the RPO threshold? For how long you want to retain data in Azure? So we provide you that capability. What is the frequency at which you want to do app consistent snapshot? So you can even retain data for 72 hours and things like that. So in this case, I already have a replication policy selected. And last but not the least, for a DR to Azure workload to be implemented, you need network bandwidth from your VMware environment to Azure. You need storage in Azure. So we have a capacity planner tool. We provide you the link to that so that you can plan your capacity and be ready. So this is a step-by-step, one-time infrastructure setup which you do and takes around minutes of time for your on-prem VMware environment. Now you have done like one-time infrastructure setup. What is the next step? Getting started answers that. So the next step is replicate your applications. Is it visible to the back? Okay. So the next step is replicate applications. So you can select the next step. Then it's again a very simple step-by-step experience where you select what is my source. And in this case, my source was a VMware environment. You select what is the target. So target is Azure. This is the point where you select a specific storage account. Which storage account in Azure you want to replicate your changes. You also select a specific Azure network so that when the VMs will be failed over, which network they will be connected to, and even the subnet for the same. Now once I have done that, I can select my SharePoint application. It has a SQL, an app tier, a load balanced web tier. So these are the 4 VMs I want to protect for my SharePoint workload protection to Azure. Now for Azure Site Recovery for VMware workload, we push a small service called mobility service in each of the workloads which you protect, be it a physical workload or be it a VMware workload. So to push that workload, we ask you for an account using which we can push this mobility service. The job of this mobility service is to intercept all the changes and then replicate them. And last but not the least, you select the replication policy. We were talking about a key capability for complex multi-tier application workloads is multi-VM consistency. So you can say, this is SharePoint. I do want multi-VM consistency. So the replication group will be called as SharePoint RG. And I want all the VMs to be multi-VM consistent. and that's it. So enabling protection for a SharePoint site is as simple as that. Now, this will start sending the data of the full SharePoint site to Azure, which will take some time. So we have another vault where the same SharePoint application is already enabled for replication. So you can come here and you can see that I have my SharePoint, the SQL tier, the web tier, app tier, and things like that. The health of them looks good. I can go inside the SQL tier and let's see what we do for compute and networks. So Azure Site Recovery discovers all the application topology, that what is the CPU, what's the memory of the VM, what's the network, and it has an intelligent algorithm by which it will automatically map the VM to an appropriate Azure size, or you can also override that. Same is, it discovers that this VM had a network interface connected to a particular subnet. It also discovers target site network properties. So in Azure, how many target networks you have, it will discover all those target network. So you select a network, it will discover what are the subnets, and it provides you a lot of flexibility. Do you want to have a DHCP IP? Do you want to inject IP? All those capabilities are available here. Now, performing a DR drill for a VM is very simple. You select the VM and perform what is called a test failover. So this is going from the on-prem site to Azure. You can select the latest processed point in time, or if you are hit by a malicious attack like ransomware. There are lots of cases in these days where the enterprises are hit by malicious attack, ransomware, and their applications are down. They have this threat from these companies. So with Azure Site Recovery, what you can do, you can failure your application, but since ransomware has attacked your source server, and we have a continuous replication to Azure, the same ransomware is now part of your VM in Azure also. So if you fail over to the latest point in time, it will have no help. That will also be impacted. However, you can say, no, I want to fail over to a custom point in time. And you can see that Azure Site Recovery has a lot of points in time available for you, defined by the replication policy you have set up for that workload. So you can say that today I have hit by ransomware. However, yesterday that was not the problem. So let me fail over to this particular app consistent snapshot, and my application will be up in few minutes. As we talk about, we provide no impact DR drill. You can select a network in Azure and then perform the failover. Now, whenever we talk about failover, our favorite scenario is a multi-VM failover with a big red button. So to enable a multi-VM SharePoint farm or any multi-VM application failover, Azure Site Recovery enables an abstraction called recovery plan. Creating a recovery plan is fairly simple. So you say plus recovery plan. It asks you the name of the recovery plan. So Ignite Demo 2016 SharePoint. Okay, what is the source? My source is a VMware environment. What is the target? I want to go to Microsoft Azure. And for Azure, we support both classic model and the resource manager model. For any new development, we strongly encourage you to use the resource manager model. Now you can select the set of VMs which you have already replicated with ASR. So for my SharePoint farm, I will select these VMs, the web tier, app tier, and SQL tier. And creating a recovery plan is as simple as that. So you select the source, select the target, and select the VMs which create a recovery plan for you. Now, a recovery plan if we go inside this recovery plan and say customize, you will see by default, all the VMs have been put in a group called group 1. However, we understand for SharePoint application to fail over successfully, there are dependencies across different tiers. So we enable you to model those dependencies with the concept called group. So we want SQL to be failed over in group 1, rightly placed. The app tier should be failed over in group 2. So let's change the group for the app tier VM. The web tier should be failed over in group 3. So let's change that. And the other web tier also in group 3. So recovery plan with groups allows you to model sequencing. It also allows you to model parallelism. So the VMs which are part of the same recovery plan, same group in a recovery plan fail over in parallel. For example, in this case, you can see both the web servers will fail over in parallel. There are no dependencies between these two workloads. However, we don't want the app server to fail over before the SQL server. Now this is great. So SharePoint will come up. However, when SharePoint is running in Azure, I have two web tiers. So for me to make sure that the proper load balancing happens, I need to create a load balancer. So for that, we have a great integration with another OMS service called Azure Automation. And you can select any group in ASR and say right click that group and add an action. You can either add an action before or after. I want to add an action after. Okay. So it asks me, do you want to insert a script or manual action? We want to insert a script. The script is load balanced web. Now it's a seamless experience where you can see all your automation accounts. Okay, somehow my mouse is not doing great. Okay, let me press F5. Okay, it's got hanged, it seems. Okay, so let's try it again. We have a recovery plan. Let me go back. So while it's coming up, the key thing I wanted to demonstrate to you that from ASR recovery plan, you can connect to your Azure Automation account and get all the different scripts like load balancer on the web tier, the RDP, and things like that. So I have this recovery plan. I'll go inside that. This is the recovery plan we want to customize. Let's customize that. So we need to add groups. And we need to move the web tiers to group 3, web tier to group 3, and the app tier to group 2. And we want to add a script. Okay, let's see if we are lucky. Okay, demo. Yes, so you can see an automation account. And once you select that, you can see all the different scripts. So I want to enable the VM load balancer, and this is how I can insert this script. And I can save this recovery plan. So creating a recovery plan is as simple as that. Yes, please. Great question. So the question is that does those scripts exist or we have to create that? So the answer is yes for both. With Azure Automation, we have an automation gallery where Azure Site Recovery team has published a set of scripts for the common tasks like port 80, load balancer, availability sets, and things like that. Also, the community can add scripts or your team can add scripts. So both the models are available for this scenario. Okay. So if I want to now perform a failover for this SharePoint farm, it is as simple as selecting that recovery plan and saying test failover. And since our test failovers are no impact, no production impact, we will select an isolated network. And that's it. So in the case when your application is down, you can perform a failover with a single button. Although in this demo, we are showing you a DR drill or the compliance scenario where on a quarterly basis, if you want to do a compliance, you can perform a test failover. Now, this will take some time. So if you want to monitor what's going on, you can go to Settings, Jobs, Site Recovery Jobs, and see the real-time status of all the failover. So this failover is going on. However, I have a past test failover of the SharePoint recovery plan. So you can see that once you press that big red button, everything is automated by ASR. So ASR will, in parallel, failover all the workloads to Azure. Then, based on your dependency modeling, it will start those workloads like the group 1, SharePoint SQL, it starts, then the group 2, then the group 3, and so on. And if you see in terms of time, in less than 30 minutes, your whole SharePoint farm is now up and running in Azure. That's the power of Azure Site Recovery, DR as a service with Azure Data Center. Okay. Okay, so just to summarize, to enable DR for this VMware workload to Azure, you have your VMware infrastructure on-premise, you have Azure available on the target. The first step is a one-time setup of this server called config and process server. And the workload which you protect, this config and process server pushes a lightweight mobility service in each of these workloads. And the purpose of this mobility service is to intercept the changes happening in those workloads, send those changes to the config and process server, which caches them, compresses them, encrypts them, and then sends it to Azure. We clearly understand our enterprise architecture needs. So you can see every communication here is HTTPS, and every communication is outbound. So no need to set up any firewall inbound ports and things like that. Yes, please. For the SharePoint? So, great question. So the question is, how do we handle domain controller failover for DR to Azure? So as I showed in the two app topologies, we support both the models. If you are a small customer where there is only one AD, you can replicate that AD with ASR and fail over that AD to Azure. We have worked with the AD team, and the guidance is that when you fail over AD, fail over to an app consistent snapshot, not a crash consistent snapshot. However, if you have an AD forest and multiple ADs, our recommendation is you use AD replication, so the AD is always running. So when you fail over the SharePoint farm, it will just connect to the AD replica copy, which is already running in Azure. Okay. So one of the most common questions we get from our customers is, this is great, we love ASR, but we have so much data. How will I send so much data to Azure? And the good news is that we have multiple options. The first option is that the config server and the process server component which you saw in the diagram has an inbuilt compression. So that's one option. Second, if you have huge amount of data, with Azure we have ExpressRoute, which gives you 10 gigabits per second kind of bandwidth, so you can send lots of data. Third, we have also worked with partners like WAN optimizers and things like that. Now when we talk about ExpressRoute, ExpressRoute provides two kinds of connection called public peering and private peering. Public peering is used when you want to connect to a publicly available Azure service like storage. As we talked about, ASR replicates the changes to storage. For ASR replication traffic, the data will go to ExpressRoute public peering channel. The other channel is called private peering, and this is used when you want to connect to a VM network in Azure. So when you fail over this SharePoint workload to Azure and you want some of your on-prem laptops or apps to connect to those workloads, that is the time you can use private peering. As we talked about, we have worked with Riverbed to do extensive testing with ASR replication and Riverbed, and the results are pretty promising. You can get 72% average compression, and there's a joint white paper published by Azure Site Recovery and the Riverbed team to enable replication from on-prem to Azure. Now, one of the most difficult tasks in a DR project is networking. Now, the good news is that ASR has a solution for each of the challenges which you hit when you do DR to Azure. The first common questions we get from our customers that, can ASR replication saturate the available bandwidth? I have an express route 10 gigabits per second. Is your replication channel efficient and take and saturate all that bandwidth? The answer is yes. We have a configurable registry key, and using that you can enable ASR replication to become hungry and use as much traffic as you want. We have seen gigabits per second kind of saturation from ASR replication. Now, with DR, the life is complex. One set of customers ask for saturation of network bandwidth. Other set of customers ask for that, hey, but I also want to make sure that ASR replication should not send so much data that my application should be impacted, because my application is also using the same bandwidth. The good news is that we also have first-class throttling experiences where you can enable settings to say for work hour, non-work hours, what is the kind of replication bandwidth you want ASR replication to use, and we will never go beyond that. One of the most interesting decisions you need to take with your DR to any target site, whether you want to retain the IP address on the secondary site or you want to change the IP address on the secondary site. Now, the good news is that ASR enables both the scenarios. However, you need to make a trade-off. If you want the full subnet failover capability, that you can retain your IP address. So if a customer says that I have these IP address coded in certain files, if I change it, something bad can happen. So we allows you to retain IP. However, in that case, you have to ensure all the VMs in that subnet fail over together. However, for the cases where you want partial subnet failover capabilities, we also provide you a capability to change the IP address, and when the VM will be failed over to Azure, ASR will inject that IP address inside the VM. So it will be a seamless experience for you. We have a lot of white papers available for each of these topics, and we have links for the same in the slide. Another interesting aspect is, for your application, you had customers all over the world. Now the application hit a disruption and you failed over the application to Azure. Now how the customers or the clients which are there all over the world will connect to this application which is moved from on-prem site to an Azure site? With ASR integration with Azure Traffic Manager, we enable a seamless experience. So your clients, which could be laptops, tablets, phone, whatever, and could be anywhere in the world, they will not need to do anything. So when the app will fail over to Azure, these clients will start connecting to that application running in Azure. So as we talked about, we support both classic and ARM model. Our recommendation is to go with ARM model. We support standard storage. We also realize for a lot of workloads like SQL, which are hungry for IOPS, you want to give them more reserved IOPS, so we support premium storage. We saw that all ASR replication traffic is encrypted and outbound, but that is not enough. We have just released ASR support for encryption at rest. For our enterprise customers, even when the data is stored in Azure storage, we gives you the capability to encrypt that data at rest in Azure storage. And last but not the least, we work with almost all the Linux distribution, and this list is continuously growing. Now today, public cloud is not ready for each and every workload. So one of the most common two limitations we see our customers hitting, one is Today, Azure allows one disk to be less than 1023 GB. However, a VM can have up to 64 disks. So you can have huge 64 terabyte VMs fail over to Azure, but if any individual disk is more than 64 terabyte, you cannot fail over those VMs to Azure. Azure does not support that. Good news is we see these scenarios a lot in DB workloads, and DB replication channels like SQL Always On works fine with that. The second common scenario we see is UEFI support. So if your VMware VM is using UEFI, today Azure does not support UEFI, so you cannot fail over UEFI enabled VMs to Azure. For our Hyper-V VMs, ASR has solved this problem where if you have a Gen 2 Hyper-V VM and you perform a failover to Azure, at runtime we convert a Gen 2 VM to Gen 1 VM. So the VM starts running in Azure, and when you fail back, it continues to be a Gen 2 VM. Last but not the least, we talked about mobility service, the lightweight service in your workload. To push this service from ASR, we need to enable WMI and file and printer sharing, a very standard way to push any software in the workloads. However, a lot of our enterprise customers also use their own methods to distribute the software. For example, we have a blog post from how you can do this with DSC. We have capability how you can do this with System Center Config Manager and things like that. Okay, so now you have set up ASR, working great with public cloud DR to Azure. What about monitoring? Once you have set up your replication, the most important aspect is to make sure replication is healthy and your application RPO, RTO needs can be met. So to enable that, ASR has got now an integration with another OMS service called Log Analytics. And in this demo, we'll show you how you can monitor ASR with Log Analytics. Okay, so this is your ASR dashboard in OMS Log Analytics, where you can see the replication health of your VMware workload. I can see there is a workload called Contoso Payroll, which is in critical health. His health is critical. Now, I may not be always available on a monitoring dashboard. So I also want to make sure that there are alerts and notifications. So I can see there is an alert for this Contoso Payroll DB went into critical state. Now to debug, let's find out what is available in the event for Contoso Payroll DB to going into the critical state. So it gives you a lot of details about why this RPO is in the bad shape. Now to troubleshoot this, let's see what's happening with the RPO trends for this VM. So we have a saved query called RPO trends and select Contoso Payroll DB. So we can see that typically the RPO was fairly small, like in seconds. However, suddenly around somewhere, maybe around 3 o'clock, the RPO has shooten up. What is causing this? Let's try to find out. So let's see what is the replication trend. Okay. Interesting. The time when RPO threshold changed, at that time we had a lot of churn happening in that VM, and suddenly my network throughput is not able to cope up with this churn. So that is causing the RPO to be out of the SLA. So with this kind of analysis, you can find out that if your RPO is in a critical state, what is causing it, maybe you can improve the network bandwidth and things like that. Now there was another alert here for Engineering Wiki DB called recovery point threshold exceeded. Okay, now let's try to debug this one. Why the RPO threshold? So let's see the replication trend. Is it a network problem? Interestingly, the churn and network throughput is matching fairly well. So unlike in the past case, we do not have any network bottleneck. Then why the RPO point is not being met? So let's try something more. What's happening to the data? So let's see the same Engineering Wiki DB VM. Interesting, this VM has 3 drives, C drive, E drive, F drive, and one of the drive is consistently churning huge churn. And we have seen primarily two scenarios for this churn. One, we have seen it will be a churn which is not useful, like in the SQL world you have a temp DB churning a lot but it's a waste churn, or in a VM you have pagefile.sys churning a lot but waste churn, and ASR enables a feature called exclude disk. So you can exclude this drive F which is churning a lot and meet your RPO SLA. We've also seen cases where this is a valid churn, that there is a valid data. So what should we do in that cases? Then why? So we see here that the churn for this drive is more than 3 Mbps. With ASR, we support both standard storage and premium storage. And our guidance is anytime you have more than 2 Mbps churn, then you should go with premium storage. So if it's a valid churn, you should move this VM to a premium storage, and then the RPO will be perfectly fine. So to summarize, ASR integration with OMS log analytics enables you to monitor your replication events, helps you to generate alerts and notifications like email, and last but not the least, gives you ability to troubleshoot the issue. Is the bottleneck in the network? Is the bottleneck in the storage IOPS? Am I sending the data which is useless? So it's better to exclude that data replication going to Azure. Now, if you want to proactively avoid these problems, ASR enables what we call a capacity planner, and there are multiple aspects of capacity you have to plan. One is about network capacity, and in a DR world you have two scenarios. One is initial replication. So when you do SharePoint enable replication, all the data of the SharePoint farm needs to be replicated to Azure. This is a lot of data going to Azure. However, post initial replication, everything is a delta. So that is what we call delta replication. The challenge comes with the peaks. Workloads have these cycles, like a payroll workload maybe at the end of the month will have peaks. So not just you have to handle IR, you have to handle DR, delta replication, and you have to handle peaks. You have to really plan your storage well, because this storage in Azure is receiving your replication traffic, so it should have necessary IOPS to support the replication traffic. Same storage also runs your workload IOPS when you do the failover. And as we talked about, we provide no impact DR drill. So in the test failover case, the storage account is getting the replication traffic, so IOPS are consumed for replication traffic. We performed a test failover, so app is also running at the same time, and the IOPS are used by both. So you have to really plan your IOPS well. And that's the reason we support both standard as well as the premium storage. And again, we have worked very closely with the Azure team, like Azure storage team has a very detailed guidance about how you should name your storage accounts. So when you create multiple storage accounts, they are spread across multiple storage clusters to give you the most optimal performance. Last but not the least, for your application to work in Azure, you need to have the necessary compute available. The biggest guidance I want you to take from this session, that to know you have the right storage, right network, right compute, perform a lot of DR drill. And with ASR, you can perform DR drill with confidence because we have no impact, no production impact DR drills. Okay, so let's have a quick demo of how ASR Capacity Planner works. So we already have a capacity planner with ASR. For some time, it's an Excel-based capacity planner. However, it used to ask customers to tell what is the churn, because based on the customer input of the churn, we have to estimate few things. And believe me or not, any meeting I have been with the customer and asked this question, what is the churn? What is the response from the customer? What is the churn? Nobody knows what is the churn for their workloads. So with this capacity planner tool enhancement, what we have enabled with ASR, that you can point to your workloads in your source environment, and we will automatically profile all those environments and tell you what is the churn. Okay, so this is the nice, beautiful report you'll get from ASR Capacity Planner. So in this case, we have profiled 34 virtual machines, 32 of those virtual machines are capable to be DR to Azure. 2 of them are not capable, and we'll try to figure out why they cannot be replicated to Azure. As we talked about, it tells me what is the network bandwidth needed for Delta replication. It also tells me what is the available bandwidth. So with ASR, we also measure how much bandwidth you have available and how much you require. So we can tell you this is the difference. As we talked about, our customer wants to do a lot of trade-offs. Like they want to see that if I want 15 minutes RPO, if I want 30 minutes RPO, 60-minute RPO, what should be the network bandwidth? Also, to handle the peaks, we have a very sophisticated capability by which you can say that although I may not hit the 100% peak with this bandwidth, but with this bandwidth, I will be able to handle 90 percentile of peak churn. Or with this bandwidth, I can handle 80 percentile of the peak churn. All of you find yourself doing these trade-offs with your business owners to get the right RPO or SLAs. We also tell you what is the initial replication bandwidth needed, 238 Mbps. And we tell you what should be your batch size. If you have 200 VMs going to Azure, you don't want to enable all 200 VMs replication at the same time, until unless you have ExpressRoute. If you have limited bandwidth, we calculate and tell you what should be your batch size to enable replication, so your network bandwidth is meeting your needs. Okay, we talked about compute, so it tells you how many Azure cores you need for those 34 VMs. It tells you how many on-prem servers you need to install. And it also tells you how many storage accounts you need. So it tells me I need 4 standard and 6 premium storage accounts, which is great. And we had that capability earlier also. But the next question comes that when a customer creates 4 storage standard and 6 premium, which account, which VM should go? It's a complex problem because each VM has an IOPS, each storage account supports a certain IOPS. So what we have done, we have also done a very intelligent placement of your VMs to those storage account. So there are 2 capabilities you get. One is, as we said, Azure Storage Guidance. So we tell you what should be the random 3-letter prefix. So your storage accounts are spread across cluster for the optimal performance. We also tell you that for each storage accounts, which are the VMs you want to pack in that storage accounts. Because we have now the answer of the most critical question, what is the churn? So based on the churn, we can place those VMs into those right storage account, and using this information, you can enable ASR replication. We also saw in the recommendation that 2 VMs were not qualified for replication. So let's see what's causing that. So we have the list of all the VMs we have profiled. So one of the VMs it's saying is not qualified. So if I go down, it says one of the disk, hard disk 1, is greater than 1 terabyte. And Azure today doesn't support greater than 1 terabyte. So this is a very powerful tool for you to assess your environment and plan both storage, how many storage accounts you need, what is the storage placement, as well as plan your network requirements, whether it's IR or initial replication requirement, DR requirement, or how do you handle the peak churn at different RPOs. Okay. So as we talked about, ASR is a single Microsoft DR solution which works for all your workloads. So far we have seen DR experiences for working from VMware to Azure. We have an identical experience when you want to do DR from on-prem to Azure for Hyper-V workloads also. So this is your Hyper-V on-premise data center, and you have target Azure. For Hyper-V to Azure, we install an agent called Microsoft Azure Recovery Services agent on the Hyper-V host. The job of this agent is to intercept all the changes, send those changes on a HTTPS outbound connection to Azure, and we support protection for just pure Hyper-V workload environments. There are customers who have Hyper-V workload environments managed by VMM. Most of the majority of data centers, you have VMM managing Hyper-V, and in that case, we also installed a component called Disaster Recovery Adapter on VMM. However, for customers who have a lot of small branch offices site which may not be managed by VMM, we also supports protection from direct Hyper-V to Azure. And like understanding our enterprise requirements, all this replication channel is HTTPS outbound. Okay, so let's have a quick demo of Hyper-V to Azure scenario. So this is a vault I have. For VMware to Azure, we went to settings, site recovery. For Hyper-V to Azure, we do exactly the same. Very much similar, you have a one-time on-premise infrastructure setup. So it says my target is Azure, my source is Hyper-V, and we support both the scenarios. The source could be managed by VMM, source need not be managed by VMM. Now, you create a site, like for the branch office scenarios, ASR asks you to define that branch office through a concept called site, and you can add individual Hyper-V host in that site. So for example, in this case, I have a PM Lab site, and I have added the host which are running in that site. The next step is identical. So you'll select an Azure subscription, and we'll validate that you have necessary storage and networking available for the DR to work. Next step is replication policy. So very much similar, the way you created a replication policy in VMware scenario, same way you create replication policy for Hyper-V scenario. And last but not the least, you can download the cool ASR recovery capacity planner from here and do the capacity planning. So this is the one-time infrastructure setup which takes minutes for your Hyper-V to Azure DR. Once you have done that, now you want to replicate your Hyper-V workloads to Azure. Again, this experience is identical. You go to step 2 and say replicate application. So my source site is the PM Lab Hyper-V site which I created first. My target is Azure, and I want to go to the resource manager, a great platform. I select a storage account, I select a network, I select a subnet. And very much similar to ASR was able to discover all your VMware environment, same discovery happens for the Hyper-V. So ASR is able to discover all your Hyper-V VMs, so you can select the VMs which you want to replicate. You can tell what is the OS, so my CRM web is running Windows IIS, my payroll DB is running Linux MySQL, and you can select a replication policy. So enable replication or enabling DR for Hyper-V to Azure is also identical to VMware to Azure. It's also identical to physical to Azure. It's a great experience irrespective of where your workload runs. Now, to get your one-click failover and things like that, you have the same recovery plans. You can select a recovery plan, perform the failover and things like that. Okay. Moving on. So when Gartner put Microsoft or Azure Site Recovery in the Magic Quadrant, one of the caution Gartner gave as part of their framework for every participant is ASR today do not have managed DR offering as provided by other partners in that space. And that is by design. Let me reiterate, ASR not having a managed DR offering is by design because we in Microsoft believes that our partners will leverage ASR and Azure to create these managed offering and offer them to their customers. That's the reason ASR has enabled support for Cloud Solution Provider program, which is Microsoft's partner program. So with this program, the partner owns the relationship with the customer, partner owns the billing, partner can provide a lot of value-add services like assessment of your environment, like capacity planning, recovery plan creation, and partner can charge a lot of money. So it's by design, we have left that space to our partners, and we encourage our partners to offer DR, managed DR service on top of ASR. We have already a set of partners which are doing that. Now to enable that, the most important task from any partner is they want to automate these capabilities. So everything which you could do from ASR portals in our demo is available through API. So ASR partners can enable these through an automated manner. So this is all about managed partners offering managed DR as a service. There is another category of partners comes into the picture called ISV partners. So for example, today Microsoft has a solution called CPS Standard from 3 partners like Dell, HP, and Nutanix. ASR has also integrated the DR story for the Dell device, HP device, and Nutanix device. So if a customer buy those CPS and standard device, create their workloads, they will be automatically enabled for DR to Azure. There is a very simple experience where we ask you whether you want DR or not, and if you want DR, we automate everything for you. Similarly, for Microsoft's own stack CPS Premium, ASR is the DR story for CPS Premium to CPS Premium or CPS Premium to Azure. Okay. So there are, if you see the Gartner Magic Quadrant, there are a lot of DRaaS providers available in the market. How do we differentiate? What are the key pillars for ASR to differentiate from the other partners? The first one and the most important one is simple and cost-effective DR. We leverage Azure as your DR site, and we have designed ASR as a first-class DR service, so you don't need to run any infrastructure component in Azure. Let me reemphasize, you don't need to run any infrastructure component in Azure, because when you run those infrastructure components in Azure, you have to worry about the cost for them, you have to worry about the management for them, you have to worry about updating them, you have to worry about availability of them, and the promise of simple and cost-effective DR is not enabled. In fact, ASR had a solution like that a year back. We have also invested a lot in our simple getting started experience as we demoed. We work across all your workloads, including physical, because we know you have physical workloads, and many times the DR for that physical workloads is even critical. Application aware. As we talked about, we provide multi-VM consistent replication, recovery plan, Azure Traffic Manager integration, so the clients are connected to the app after failover. We think about DR not just data replication. There are enough vendors there who can do that. We don't think DR as a VM replication. There are enough vendors who can do that. We think about ASR as application availability. So even when we bring the whole ASR SharePoint farm available in Azure, we also go the last mile to ensure your client connects to them by integrating with Azure Traffic Manager. And last but not the least, enable a converged backup and DR experience from the same site recovery vault. So as an IT admin, you get the same site recovery vault where you can manage your backup as well as DR. So we understand our enterprise customers' requirement that they have the needs for compliance, they have the need for security. The good news is ASR has majority of the critical compliances and security certifications, so you can trust on Azure Site Recovery to offer you DR and migration. ASR is available as part of OMS Suite. So this is the OMS Suite which was launched during this Ignite. So you can see it has multiple packages. ASR is part of protection and recovery package, which you can get at a particular price point. Or you can buy a E2 OMS E2 package where all the components are available. So our recommendation is for you to buy either OMS E2 or protection and recovery bundle to buy ASR. That's our recommended model because you get a lot of value at a huge, huge discount price. However, in the worst case where you cannot have the use case for any of those components, ASR is also available as a standalone offering. Yes, please.
What is the plan for supporting workloads on other hypervisors like Acropolis, XenServer, Graph?
Sure. So let me repeat the question. The question is, what's the plan to support other hypervisors like Xen and so on? So today, when we did our market analysis, we found that with VMware and Hyper-V, together we have covered, I don't know, it's maybe 90% of the market. So we have enabled the first-class experience for VMware as well as Hyper-V. However, with ASR support for physical appliances or physical workloads, you can protect any of the other virtualization platform like Xen. The difference will be they will be protected as physical workloads. So that is possible today. One important information for ASR that as it's a first-class public cloud DR service, at a steady state, you only pay for ASR subscription and the storage, depending on how much storage you're using. Only when you do the failover to Azure, ASR brings all the SharePoint farm in Azure, and then the SharePoint farm is running in Azure as Azure IS. So if you run there for 2 days, 5 days, 1 week, you will pay Azure IS charges only for that period. So it's truly pay-as-you-go DR and doesn't require you to run those workloads all the time. Sorry, our bad. So our engineering team loves to call a site-to-site scenario E to E, enterprise to enterprise. So when you want to use ASR to protect your workload from site A to site B, we have a set of customers who do that. So the pricing for that is $16 per node. We also have our hero scenario of doing DR to Azure, which we call E to A. I don't know, fairly obscure name, which is $25 per node. Okay, just give me a few minutes. I'll come back to that. So one last thing. So far we have seen on-prem to Azure DR. And it's a very compelling scenario for our customers who are in this journey of adopting public cloud. And it gives them a great scenario where they have all the control, all the power to run their workload on-premise. And only for DR needs they use Azure. We also have a set of customers who have reached to the maturity curve in the public cloud and already running those workloads in the public cloud. And when they run those workloads in the public cloud, a lot of enterprise customers, and many of them are available here, says that when I'm doing public cloud workloads, my compliance needs are almost identical. I still need to do a DR drill for my workload. Although Azure IS gives you a great platform, always available and so on, but my application is ISO 2000X certified, and to continue getting that certification, I need to prove every quarter a DR drill. Today, there is no public cloud. There is no public cloud in the whole world which allows you to do DR drill at your choice, at your time, and get those certification. So today, for the very first time, we are showing you Azure Site Recovery for your workloads running in Azure. And I'm really excited to show you that scenario because this is a sort of a dream scenario we imagined when we started ASR to make DR really simple. And this scenario has reached that simplicity. So let me show you how it works. So this is your Azure portal where you can see all the virtual machines which are running in Azure. So I have an app called Contoso app running in Azure. And I want to enable DR for this workload. Now, if you are familiar with ASR, you'll think about, I have to do one-time infrastructure setup that will take some time, then I have to do this, then I have to do that, which is also very, very simple compared to the DR state. But with Azure Site Recovery, we have redefined simplicity. So you select your application, select Site Recovery, and that's it. We discover all the information for this workload running in Azure. We'll discover what's the compute property, what's the storage property, what's the network property. And not just we discover all those property, we also create those storage account, network, etc. on demand in Azure. So you don't have to do anything. The only thing we ask you to do is select where you want to do DR. Like you can go to your favorite. So for example, here I have selected, I want to go from my data center in Asia to US. So enabling DR for a workload is as simple as clicking a button. Everything is done by ASR. Now the same thing is true for failovers also. So let's select a workload which is already enabled for DR, Contoso app VM, and select the same site recovery. And we can see this workload is already enabled for DR, so the replication health and so on. And performing a DR drill is as simple as clicking a test failover button and selecting a virtual network. That's it. So this is DR simplicity redefined for running your workloads in Azure and giving you power to do DR drill at your choice, at your time, and get your certification for your workload. Okay, the good news that Rochak, who's the PM lead driving Azure to Azure, has a very in-depth session tomorrow at 9 o'clock. Shucks. So please join that session where we'll cover DR for your Azure workloads in depth at 9 o'clock. Okay, that's it. Any questions?
I didn't see master server in your whole picture. So is it out or it was supposed to be there?
Right. So in the past, in the past we have a component called master server for configuration. Now we don't need that component running in Azure. As we were saying, there's a lot of DR technologies which require you to run component in Azure. Now we have really made it PaaS, so you don't need to run any master target server in Azure. Yes, and you need that config and process server only on the on-prem server. Yes, please.
Two questions, please. One, do you know when Azure will support Gen 2 VMs so we can do things like shielded VMs with ASR?
Great question.
In the Azure, the site recovery between two VMs, if you need to still consider like geo-replication on the storage.
So you don't need to depend on geo-replication on storage, because geo-replication on storage is not app consistent, it's not multi-VM consistent, and it doesn't let you to fail over at your own time. So that provides DR for Microsoft's own data and services. For application DR, which are your application, our story is Azure Site Recovery.
Right, so generally you might have geo-replication on your virtual machine. Can I back that down to just local because now I can use it?
That is correct. With ASR, you don't need then GRS for your VMs. That is correct.
And so on the first question, any idea on supporting Gen 2?
Unfortunately, I don't have any timelines to share with you at this point. Yes, please.
In order to get the churn or capacity planning report that you showed, what are the prerequisites? I tried to walk through it.
Sure.
Is it going to impact my production servers if I'm
So,
install agents?
so great question. That to get the capacity planning report, what are the prerequisites? And we hear a lot from our customers that they don't want to do a lot of install, etc., to get this data. So we hear you. This tool is a tool which you can install on your laptop or on any server, and everything it does remotely. So there is nothing you need to install on the workloads. So everything is remote profiling. Just
Kind of like the maps tool.
that is correct. Very much like that. Yes. Yes, please.
Do you have any white papers or information showing when you're doing site-to-site instead of Azure, what functionality or what features you don't have?
So when you're doing site to site, the ASR experience is identical. So you will do identical, everything is same. You will do enable replication, you'll do recovery plan, you'll do failover, almost the identical experience for Hyper-V site to site. For VMware site to site, we don't have an identical experience because that is a technology we acquired with a company called InMarch. And for our VMware to Azure, we have totally integrated that technology inside ASR and made that as a first-class DR service. For VMware to VMware, it's still the same experience before acquisition. Yes, please.
How about basically the 1 terabyte size of more than 1 terabyte size? Is there any pipeline or any timeline for that?
So again, I can't share any timeline. There are some workarounds available, like if you can distribute your big disk into multiple disks and do striping and all, but I know that it's not easy. That's the reason I'm not recommending that as a very often.
How about the ASR with Store Simple? Will the limitation still remain the same, or is it going to change the 1 terabyte of?
So that's a good point you made, that if you're using ASR with the Store Simple, you can overcome that 1 terabyte limit with ASR plus a Store Simple.
I need a Store Simple virtual appliance in the Azure as well.
That is correct. Yes, please.
This earlier, implications of a block for Azure and Azure DR,
Implications of?
block-based applications.
implications of blob-based applications. So today, Azure to Azure DR, we are enabling for Azure IS VMs for your enterprise applications which are running in Azure IS. And VMs run on page blob, so it is enabled for page blob. We have not enabled this for any other types of blobs.
I have another question, which is related to the resource group selection when we are migrating it. Is it still a random one, or we can pick the
Great question. So in the demo, you saw that when ASR fail over a workload or migrate a workload to Azure, and tomorrow's session with Rochek, I could not cover a lot of migration capabilities. Rochek will spend a lot more time on migration. One of the big feedback we got from our customers that today ASR was auto-creating the resource group. What we learned from you that resource groups are already created in your enterprise with your own planning about apps or departments or whatever is your policies, and you want ASR workloads to be failed over or migrated to those resource group. The good news is that that feature is coming very, very soon. With ASR is a public cloud service, we release almost every month. I'm not committing any date, but we'll surprise you very soon with that feature.
One more question about the dynamic disk. If I'm using a dynamic disk, is there any limitation when I'm doing a replication of my?
Great question. You have used ASR fairly well. Yes. So dynamic disk. So we do support dynamic disk for any disk other than OS disk, because Azure support dynamic disk for data disk, not for the OS disk. So as long as you have dynamic disk for data disk, we'll be able to support. That is correct. I mean, you have to realize that ASR is failing over workloads from on-prem to Azure. Whatever are the Azure characteristics or limitations we inherit, there are times where we overcome those. For example, Hyper-V Gen 2 case, in ASR layer, we do the Gen 2 to Gen 1. In Hyper-V VHDX case, we do VHDX to VHD. Retain disk, we do a lot of things depending on the feedback, but there are some we just inherit. Yes, please.
So if you're failing over the machine and you're having it get a new IP, is there any kind of integration with regards to DNS, or is that something you do through an automation and do DNS?
Yes. So we do not have any first-class integration with DNS. When you get a new IP, you can use Azure automation scripts to update the DNS is the current story. Yes, please. Great question. So Azure VM has recently announced multiple IPs per NIC, a very cool feature. So we talked about a capability of ASR can retain IP, but then you have to fail over the full subnet. And if you want partial subnet, you can't retain the IP. So with some of the cool capabilities like multiple IPs on a NIC, we are exploring solutions where we can even enable you to retain IP with partial subnet. It's a very early thinking at this point. Okay, thanks everyone.